I'm now going to teach you how to compute the trigonometric functions from a given right angle triangle. Let's see a typical problem. So let's see what we've got. Let's read the problem first. Let the angle theta be as indicated in the figure. So I don't know if you see the angle theta. There it is, okay? So that's the angle theta. So let the angle theta be as indicated in the figure. The problem now asks us to find the values of the 6 trigonometric functions of theta. So we need to find sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. All right. Now, we already studied how to find the 6 trigonometric functions from a right angle triangle if we know all 3 sides of the right angle triangle. But on this particular triangle, we only know 2 of the sides. We know that this side here has length 4 units, and we know that that leg here has length 3 units. So that's all we know. All right? However, we do remember that we can actually find the 3rd side of that triangle. So, how does that work? Well, see, what's this side here? What's this side here equal to? This side of our triangle. So, since this is a right angle triangle, this side here would be called the hypotenuse of the triangle. So what is the hypotenuse of that triangle? How do we find the hypotenuse of a triangle if you know the 2 legs of a triangle? Well, all you need to do is use the Pythagorean theorem. Now, the Pythagorean theorem tells you that the hypotenuse is equal to the radical of the squares of the sum of the squares of the 2 small legs of the right angle triangle. So the hypotenuse of that triangle is equal to radical of 4 squared. 4 is the length of this leg, plus 3 squared. 3 is the length of that leg over there. Okay, so 4 squared plus 3 squared. You add those two squares, and then you take the radical. That's what the Pythagorean theorem, one of the corollaries of the Pythagorean theorem says. All right. So the hypotenuse is radical of 4 squared plus 3 squared. Now, 4 squared equals 16. 3 squared equals 9. So 4 squared equals 16. 3 squared equals 9. So that's 9. So altogether, 4 squared plus 3 squared must be equal to 16 plus 9. So that must be 25. So that must be 25. Okay? So we get a radical of 25. And the radical of, so 25 is of course equal to 5 squared. So, our hypotenuse here has length a radical of 25. So that is exactly equal to 5. All right. So now we know our hypotenuse. Next, once we know the 3 sides of our triangle, the rest is easy, right? In order for us to find sine of theta, well, sine of theta equals the opposite side over the hypotenuse. So sine of theta must be equal to 3/5. The opposite side has length 3 units, and the hypotenuse has length 5 units. So sine of theta equals the opposite side. So once again, sine of theta equals the opposite side over the hypotenuse. So 3/5. Next, cosine of theta. Can you guess? Well, I guess you guessed correctly. So cosine of theta must be the adjacent side over the hypotenuse, right? So cosine of theta must be the adjacent side over the hypotenuse, which must be 4/5. All right. Next, tangent of theta. Well, what was tangent of theta equal to? Well, I'm sure you remember that tangent was computed by taking the opposite side and dividing it by the adjacent side. So tangent of theta must be equal to 3 divided by 4. Next, we need to compute cosecant of theta. And now, just to remind you, cosecant of theta, that's actually 1 over sine of theta. So you can just take the reciprocal of 3/5. So the answer should be 5/3, right? The answer should be 5/3, but you could also compute it as the ratio of sides. You can compute it as the hypotenuse, which has length 5, divided by the opposite leg. Okay, so of course all of these three quantities are all equal. Next, we need to compute secant of theta. Now, if you recall, secant of theta is 1 over cosine of theta. So all I need to do is take cosine of theta and flip the numerator and the denominator. So secant of theta, that's 1 over cosine of theta, which is, of course, it must be exactly, you guessed it, 5/4. So secant of theta is 5/4. That is 1 over cosine, or what is the same, the hypotenuse divided by the adjacent. And finally, cotangent of theta. Well, cotangent is 1 over tangent, right? So that guy here, that is 1 over tangent, right? 1 over tangent of theta, right? So, or what is the same, if you will, the adjacent side over the opposite side. So we can just take 1 over tangent. Well, that's, I guess, 3/4. So if you take 1 over 3/4, you're, of course, getting, well, I'm sure you've guessed it by now, you are getting 4/3. So here's our final answer. All right. Now, let's solve that in the context of our homework server. So we're done with the general instructions. So now what I'm going to do right now is I'm going to switch to the web browser, go to the problem, the corresponding problem in our homework server, and there I'm going to show you how to solve that problem in the context of our user interface. All right, so I'm going to switch now to the web browser, and I'm going to switch to this particular problem. All right, let's select the problem. There we are. All right. Now, you will notice that in this particular problem, the right angle triangle, here's the right angle triangle, is not oriented in the way in which it was set up in the slides. Okay, that is on purpose. I'm trying to add extra difficulty to the problems. All right. So next thing you're going to notice is that the right angle is in this unusual place here. That's okay as well. Next thing you're going to notice is that, well, actually the angle theta is not very easy to see in here. I'm zooming with the mouse wheel right now, and you see here's the angle theta. All right. So here's my angle theta. And what else do I know? I know this side of the triangle. It's indicated to be 4 units. And I know that side of the triangle, which is indicated to be 1 unit. Okay, so I know 2 of the sides of my triangle, and I know the angle theta. Of course, the problem asks us to do the same thing as what is on the slides, but let's make sure by reading the problem. Let theta be the angle indicated in the plot above, so with this angle theta. Let's find all the 6 trigonometric functions from that angle theta. So first, let's start with sine of theta. Now, sine of before we start with sine of theta, just as in our lecture slides, we need to find the hypotenuse. Now the hypotenuse is equal to the radical of the two sides. So the hypotenuse in our triangle is equal to radical of 4 squared plus 1 squared. So 4 squared is 16 plus 1, that is 17, so radical of 17. So our hypotenuse is radical of 17 units. All right. And now we're ready. Sine of theta, what's that equal to? Well, if the hypotenuse is radical of 17, then sine of theta must be the opposite side divided by radical of 17. Now, we have to be extra careful here. Which side here is the opposite side? Well, if this angle here is the angle theta, then that side is opposite to theta. So the opposite side here is 1, and the hypotenuse is radical of 17. All right, so let me click submit. Okay, that is correct. So just a reminder, the hypotenuse was radical of 17. Now, next thing we need to compute is cosine of theta. Now, cosine of theta, that was the adjacent side over the hypotenuse. The adjacent side, I'm not sure if you remember from above, but that was 4. The hypotenuse is still radical of 17. So our answer should be 4 divided by radical of 17. Okay, worked like a charm. Now, tangent of theta, that is opposite over adjacent side. The opposite side had length 1 unit, the adjacent side has length 4 units, so that would be a quarter. Okay? Next, cotangent of theta. Well, cotangent of theta is 1 over tangent, so that would be 1 over 1/4, right? Or which is the same, 1 over 1/4 is of course equal to 4. So 4 will be our cotangent of theta. Of course, we could also try adjacent side over opposite side, right? We could try that as well. Secant of theta. Well, just a reminder, secant of theta was 1 over cosine of theta. Okay, so secant of theta, that's the same as 1 over cosine of theta. So secant of theta is so that would be the hypotenuse divided by the adjacent side. So the hypotenuse divided by the adjacent side, well, we remember that our hypotenuse was square root of 17, and the adjacent side was that was 4, right? So radical of 17 over 4. All right, that went through as well. And finally, cosecant of theta. Just cosecant of theta, just to remind you, that was 1 over sine of theta, which is the same thing as the hypotenuse divided by the opposite side. So the hypotenuse was square root of 17, and we divide square root of 17 by the opposite side, which had length 1 unit. Well, of course, let's not divide over 1, so let's enter our answer as radical of 17, and that went through as well. All right, so that concludes this example. Good luck with the problems in our course.